Hello guys, we will study the alcohol, phenol and ether topic. In previous lecture we will study the physical properties of alcohol. In that it should be studied the solubility and boiling point of alcohol. Now in this lecture we study the reactions of alcohol. This is a reactions of alcohol. Now, or it is a chemical properties of alcohol. Okay guys, the chemical properties or reactions of alcohol. In this point, the alcohol, that is commonly we consider this a alkyl group O and H. This is the alcohol. In this alcohol, the alcohol functional group, that is hydroxy group. In this hydroxy group, oxygen contains the lone pair. Due to this lone pair, oxygen attracts the electrons from hydrogen towards itself. Oxygen attracts the shared electron from hydrogen towards itself. That means in between oxygen and hydrogen atom, there is a polar bond is formed, because after donating the electron from hydrogen to oxygen atom, hydrogen it becomes a partial positive charge and oxygen it becomes a partial negative charge. This is a first point. After that, this oxygen or this alkyl group also donates the electron to the oxygen atom. As well as the electron density goes on increases around the oxygen atom, and this alkyl group shows the partial positive charge. Okay, this is the nature of alcohol. Okay, but in these chemical properties or reactions of alcohol, the alcohol is act as a, sometimes it also act as a electrophile, or firstly we consider the nucleophile, or sometimes the alcohol act as a electrophile. Okay, then alcohol act as a nucleophile. That means after making the nucleophile, the nucleophilicity of alcohol goes on increases, but what it should be happens, then this nucleophile of alcohol or alcohol it becomes a nucleophile by breaking of bond between oxygen and hydrogen atoms. That means this nucleophile is formed by cleavage of bond between oxygen and hydrogen atom. This is a bond cleavage between oxygen and hydrogen atom. And after that, or sometimes the alcohol acts as a electrophile. In this electrophile, the alcohol becomes a partial positive, it becomes a electron deficient species. This electron deficient species is formed by breaking of bond between hydroxyl group and this alcohol. This bond should be break down. That means for the formation of electrophile of alcohol, the cleavage is happening in between the bond between R and OH group. That means the bond should be break down in between alkyl group and hydroxyl group. Okay, there are two different bond cleavages are here. In first bond cleavage, that means the oxygen and hydrogen, the bond between oxygen and hydrogen it should be break down. After breaking, there is a formation of nucleophile. After that, the bond it should be also break down in between alkyl group and hydroxyl group. Hydroxyl group containing oxygen and alkyl group. This bond is break down. This alkyl group, this oxygen containing hydroxyl group. In between this bond, it should be break down. After breaking of this bond, the alcohol is act as a electrophile. Okay. Then we study the reactions or chemical properties of alcohol, but in that the alcohol shows the two types of reactions. In first reaction, it should be carried out by cleavage of bond between O and H. This bond it should be break down. After breaking of this bond, the alcohol act as a nucleophile. Nucleophile means electron-rich species. Nucleophile contains the more electrons are present in a ion. Okay. The second is a cleavage of bond between alkyl group and hydroxyl group. This bond it should be break down. After breaking of this bond, there is a formation of electrophile. Electrophile means the species which containing less number of hydrogen atoms. It is a electron rich species, and this electrophile it is a electron deficient species. Okay. The chemical reaction or chemical properties of alcohol is happening on the basis of these two types of bond breaking. Okay. Now the bond it should be break down in between oxygen and hydrogen atom. The bond it should be break down in between oxygen and hydrogen atom. Then it forms a nucleophile. And what is a mechanism when it becomes a nucleophile of alcohol? Is that the mechanism is that if the alcohol or this alcohol is reacted with electrophile. Alcohol is reacted with electrophile. Okay. In this case, the electrophile, it is a electron deficient species. In this case, alcohol is act as a electron deficient species. But this nucleophile is in this electrophile, we consider any carbocation. There is a carbon. There are any alkyl groups are attached here. This is a carbocation. This carbocation is an electron deficient species, and this oxygen it carries a lone pair. By using this lone pair, this oxygen attacks on the carbocation. Okay. After attacking on this carbocation, there is a formation of R, O. This is a H, and this carbon is attached to oxygen atom. That means the new bond it should be generated in between carbon and oxygen atom. After bond formation, the oxygen use a one extra lone pair, and therefore this oxygen carries the positive charge, and there is a formation of a protonation. There is a formation of protonating product. After this protonating, the bond between oxygen and hydrogen atom, this bond is delocalized on the oxygen atom, then it forms a R O C. Okay, this is a mechanism of alcohol. It becomes a nucleophile, or by act as a nucleophile. Okay, and after formation of ether, there is a formation of H plus ion. There is a formation of H plus ion. This H plus ion it should be generated from this hydrogen atom after delocalization of bond on the oxygen atom. Because then in this case, this alcohol act as a nucleophile. This is a electrophile. Okay. In this case, if the alcohol act as a nucleophile, then alcohol in that the attacking center is a oxygen. This attacking center of oxygen it attacks always on the electrophile. That means if the alcohol it act as a nucleophile, then always attacks on the electrophile. Okay, this is a common mechanism of cleavage of bond between oxygen and hydrogen atom. After breaking of this bond, the alcohol act as a nucleophile. This is a common mechanism. After that, we comes towards the cleavage of alkyl group and hydroxyl group. Alkyl group and hydroxyl group. After breaking of bond between alkyl group and oxygen, the alcohol act as a electrophile. Okay. Okay. Consider the alcohol. This alcohol acts as electrophile. We consider the electrophile is reacted with nucleophile. Okay. Then nucleophile always attacks on the electron diffusion species in this alcohol. In this alcohol carries a lone pair. That means in hydroxyl group, the oxygen carries the lone pair. Because of this lone pair, this carbon atom directly attached to the oxygen atom, which contains the partial positive charge. This hydrogen is present in a partial positive charge. That means the hydroxyl group containing hydrogen, it is in acidic in nature. Okay. Therefore, it is present in H plus ion. Okay. Then this Br minus acts as a nucleophile. This nucleophile attacks on the carbon atom. This Br minus attacks on the carbon atom. After that, the OH minus it should be eliminated. But in this case, this OH minus is a not a living group. This is the most important point. The OH minus is a not base living group. Therefore, by using Br minus, the OH minus it not be eliminated. Is not be eliminated. Therefore, or it is a not base living group. Therefore, for preparation of electrophile, direct attacking of nucleophile on the carbon atom which is present in a alcohol is not possible. That is, electrophile of alcohol is not generated directly by attacking of nucleophile. Okay, but it forms a protonation of alcohol. That means the electrophile is generated by the protonation of alcohol, not directly attacks the nucleophile on the electrophile. Then we can see the point of protonation of alcohol. Okay, why protonation is required? Because in case of hydroxyl group, after attacking of nucleophile on a hydroxyl group, the hydroxyl group is not act as a base living group. Therefore, direct electrophile generation is not possible here. Then, after protonation, the alcohol act as a electrophile. That means this is a alcohol. In case of alcohol, the oxygen carries the lone pair. It is again reacted with H plus ion. H plus ion we consider the acid. That is, we also considered as a proton. Okay. By using this oxygen, one lone pair carried. Out of these two lone pair, by using one lone pair, this oxygen is attacks on the H plus ion. That means by using one lone pair, oxygen forms a new bond in between oxygen and hydrogen atom. There is a formation of a protonated alcohol. In this protonation, the one lone pair goes on decreases and one lone pair remains here. Therefore, the oxygen carries the positive charge. In case of alcohol, this hydroxyl group is not a base living group. But after protonation of hydroxyl group or after protonation of alcohol, this group is act as a base living group, because in this molecule, the water molecule it should be generated. In this molecule, water molecule it should be generated. After generation of this water molecule, the water molecule it should be eliminated. But at the time of elimination, oxygen carries this electron pair towards or with itself. Then it forms a R plus and one water molecule it should be generated. From this reaction, from this mechanism, the alcohol is act as a electrophile. Alcohol act as a electrophile. After formation of electrophile, any weak nucleophile or any weak base is easily attached on this electrophile of alcohol. Then it forms a product. That means in these two types, The cleavage of bond, it should be formed in between two ways. In between the breaking of bond between oxygen and hydrogen, there is a formation of nucleophile, and breaking of bond between alkyl group and oxygen atom, there is a formation of electrophile. But electrophile, it is a direct electrophile formation is not possible. Therefore, this electrophile is generated according to, or it undergoes the protonation of alcohol. After protonation, the water molecule, it should be eliminated. After elimination of water molecule, there is a formation of electrophile. After formation of electrophile, the Br minus, that means the any nucleophile which is having a weak nucleophile or which is having a strong nucleophile, this nucleophile attacks on the carbon atom or alkyl group, there is a formation of a product. Okay, these are the some chemical preparation methods, general preparation methods or general chemical reactions and its mechanism by cleavage of bond between oxygen and hydrogen, cleavage of bond between alkyl group and oxygen atom. Okay, after that, in case of alcohol, the alcohol carries one alkyl group and one hydrogen atom. Okay, then because of oxygen shows the electronegativity, it attracts the electron pair towards itself. This alkyl group shows the partial positive charge, and this hydrogen shows also partial positive charge. Okay, then electron density goes on increases or surrounding around the oxygen atom, then this oxygen carries the partial negative charge. This oxygen carries partial negative charge. Okay, that means this hydrogen is present in the form of H plus ion. Therefore, this H plus we can consider the acid. In short, in alcohol, the alcoholic functional group which contains the hydrogen is in H plus form. That means this hydrogen is present in acidic in nature. This hydrogen present in a acidic in nature. Okay. Then according to this concept, this hydroxyl group or this alcohol, it donates the H plus ion. This hydroxyl group, it donates the H plus ion to any other electron rich species. Okay, therefore it is a Bronsted Lowry acid. Therefore, this alcohol, it is a Bronsted Lowry acid or Lowry Bronsted acid, because it donates the H plus ion, because it donates the H plus easily to other electron rich species. Okay, then suppose this is a general alcohol, it is reacted with base. Base shows the negative charge because base contains more electrons. Okay, therefore the electron density goes on increases, or it should be higher as compared to acid. Therefore base any base is used. This base shows the negative charge. This is a alcohol. In this alcohol contains a acidic hydrogen, because this hydrogen is directly attached to the oxygen atom. Therefore this alkyl group, this alcohol, it donates the electron easily to the base. Okay, by attacking of this base to this hydrogen atom, because acidic nature of hydrogen, okay, it donates, that means this alcohol donates the H plus ion to the base. This alcohol donates the H plus ion to base, that means it is a proton donor. It is a proton donor, therefore it is an acid. Therefore it is a acid, and this one is a base. This one is a base. Okay, we know well the acid, it forms their conjugated base, and base, it forms their conjugated acids. After donating the H plus ion to the base, then it forms a BH and RO minus. Okay, the H plus ion is combines with base, there is a formation of base containing a H plus ion, and the one H plus which is after donation to the base, the alkoxide ion it should be formed. Okay. In this case, there is acid. Why it is called as acid? Because which contains the hydrogen ion. Okay. In this acid, the alcohol we consider the acid. After donation of the H plus ion, the H plus ion it should be less. That means therefore it is called as a base. Okay. In between base it is not contains a hydrogen atom. After bond it should be formed in between base and hydrogen. There is a acid. Okay. Therefore, this acid it forms their conjugated base. Okay. Therefore, it is called as a conjugated acid base pair. It is called as a conjugated acid base pair. Okay. Now this base is get converted into their acid respective acid. Then base it forms their conjugated acid. Therefore it is called as a conjugated base acid pair, or it is also acid base pair. Okay. This is a nature, or this is a acidic nature of alcohol. Okay. After attacking of base to H plus ion or alcohol, it donates the H plus ion to the base, then it forms their conjugated acid, and alcohol it forms their conjugated base. Okay. This is a acidic nature of alcohol. Okay. Then commonly alcohol it is called as a Lowry-Bronsted acid because it donates the H plus, that means the proton, easily to the electron rich species, or it donates the H plus ion easily to the base. Okay. Then after that we can show the first chemical properties of alcohol. Before that, we will write down these notes, and this is the most important one. Okay. Okay. Now we see the reactions of metal. First reaction, there is a reaction of alcohol with metals. Here we consider commonly M. In this case, or metals, we consider the group first and group second. In that, we consider the sodium, potassium, magnesium, calcium, as well as we also consider the aluminium. These metals are reacted with alcohol. Okay. In this case, now we consider commonly metal is denoted by M. Okay. In this case, the M, that means this alcohol is reacted with M. M we considered here as metal. In that, sodium, potassium, magnesium, calcium, or we also consider as a aluminium. Okay. The metal is always donate the electron. The metal always donate the electron. Okay. Or these metals which is from group first and group second, therefore it shows +1 oxidation state, it shows also +2 oxidation state, as well as this aluminum we will consider from the p block element, therefore it also shows the +3 oxidation state. And most important point is that if the metal is reacted with alcohol, if metals are reacted with alcohol, then it forms a hydrogen gas. Then it forms a hydrogen gas. Okay. Then alcohol is reacted with metal. Then firstly, hydrogen gas, it should be eliminated. Okay. Now we see here there is a alcohol and this one is a metal. In this reaction, the metal is reacted with alcohol. Okay. This metal is a electron deficient species. Therefore, on this metal there is a positive charge here. Okay. Then this metal shows the positive charge, and this oxygen carries lone pair. This oxygen carries lone pair. Then after attacking of the or after reaction of metal with alcohol, there is a elimination of hydrogen. There is a elimination of hydrogen. We know that the H plus ion which is present in alcohol is in acidic in nature. Therefore it is a H plus ion. Both these H plus and these H plus is combined with each other, then it forms the H2. Therefore, 2 hydrogens are required to elimination of H2. Therefore, this alcohol is balanced as using a stoichiometric coefficient. By using 2, there is 2 hydrogens are eliminated. Then, after elimination of 2 hydrogen, there are 2 alkoxide groups are formed. And there are if electron deficient metal is here, and these 2 alkoxide groups are generated out there. In there, the oxygen shows the negative charge. This negative charge oxygen is combined with metal, but metal we consider also or we taken in a 2. Okay, then this metal is combined with oxygen, then it forms a metal oxide, alkoxide. Then it forms a metal alkoxide. By taking this example, this is a ROH group is reacted with sodium. Sodium shows the positive charge. Okay. When metal is reacted with alcohol, then hydrogen gas, it should be eliminated. For hydrogen gas, this reaction we can be balanced. There are 2 alcohol molecules are used. There similarly 2 Na plus ions are also used. There are 1 hydrogen atom, 1 H2 molecule should be eliminated, and there is a formation of sodium alkoxide ion. Then it forms a sodium alkoxide ion. Okay. After that we take potassium. There is a K plus. The sodium and potassium show the similar reactions. There are 2 K plus ions are here. There are 2 alcohols are here. Then metal or potassium is reacted with alcohol. There is a elimination of hydrogen gas, and then it forms a potassium salt of alkoxide ion. Okay. In this reaction, sodium and potassium combines with alcohol. There is a elimination of H2 gas. Okay. After that, we also consider the magnesium, aluminium, and calcium. Okay. After that, we consider the example, that is a CH3CH2OH is reacted with magnesium. Magnesium shows the +2 oxidation state because metal it donates the electron. Okay. Then it forms, or from that the H2 gas is eliminated, and there is a formation of CH3CH2O- and there is a Mg. Okay, Mg here shows the +2 oxidation state. Therefore, 2 alkoxide ions are attached to the Mg. Therefore, twice alkoxide ions are used. Therefore, by using twice alkoxide, there 2 molecules of alcohols are also required. Okay. Then it is known as a magnesium ethoxide. Okay. After that, we see the reaction of aluminium. The aluminium shows the +3 oxidation state because 3 electrons donates from its outermost shell. Then this Al3 plus, we can take the same alcohol, that is any kind of alcohol, it should be used here with reaction with metal. There are 3 aluminum shows the +3 oxidation state, that means, or commonly when metal is reacted with alcohol, there is the elimination of hydrogen gas, plus aluminum carries +3 oxidation state, that means the 3 alkoxide ions are required to combine with 1 aluminum, that is a CH3 CH2 O minus thrice Al. Okay, 3 alkoxide ions are required to come of aluminum is here. From this product 3 alcohol molecules are used. Okay, then this is when alcohol is reacted with aluminum, there is a formation of aluminium ethoxide. There is a formation of aluminium ethoxide by using aluminium or alcohol, then it forms the aluminium ethoxide. From these reactions, that means when alcohol is reacted with Na+, when alcohol is reacted with K+, when alcohol is reacted with Mg2+, when alcohol is reacted with Ca2+, when alcohol is reacted with Al3+, then alcohol gives their respective salts. Alcohol gives their respective salts, their corresponding salts. By using this reaction, one of the most important point is that when magnesium or any other metal is reacted with alcohol, this magnesium or this metal is replaced to the hydrogen atom, which is from the hydroxyl group. Okay, this magnesium ion is replaced to the hydrogen atom, which is in hydroxyl group. That means this positive charge or this electron deficient species is replaced to the H plus ion. That means this positive charge is replaced to the positive charge species. That means after elimination of hydrogen gas, this hydrogen is eliminated or it goes to the outside in the form of H plus ion. That means these reactions is the evidences of acidic nature of alcohol. Acidic nature of alcohol. Okay. Then this is a chemical reactions, as well as in that firstly we can say the 2 types of cleavages here. First cleavage, the bond it should be break down between alkyl group and oxygen atom. After that we show the bond it should be break down between between alkoxide ion and hydrogen atom. After that the first reaction is when alcohol is reacted with metals, and then it forms the respective their alkoxide ion, and these reactions, that means reactions of alcohol with metal, it is a evidence to determine the acidic nature of alcohol. Okay. This is the most important point for the chemical preparation, chemical properties or reactions of alcohol. Okay guys, thank you.